Hello everyone, imagine being able to ask your data anything and getting the perfect answer instantly. In just 30 minutes, we will explore GraphQL, a tool that makes this possible. We will cover what GraphQL is, why it's better than REST API, and how you can use it to supercharge your data queries and updates. Plus, there's a hidden feature we will reveal at the end that could totally change how you think about data. Ready to become a GraphQL pro? Let's get started and unlock the secrets. Hello everyone, welcome to the course on Introduction to GraphQL. In the agenda, we will be discussing Introduction to GraphQL. We will see the characteristics of GraphQL and the differentiation between your GraphQL and your REST API. We will also see the benefits and challenges of GraphQL. We will see what are the things involved in creating a GraphQL schema. We will try to understand what is types, fields, and resolvers. We will also understand the concepts of aliases and fragments for query optimization, as well as we will see how making changes to data with mutations is possible. And then we will explore some GraphQL development tools. So coming on to your GraphQL, a GraphQL is a new API standard that was invented in 2012, and Facebook invented this in 2012 and it open sourced it in 2015 so that everyone can use this GraphQL and utilize the advantages which GraphQL gives over your REST API. Now, what exactly is GraphQL? How exactly GraphQL helps you out in having the communication between your client and your servers? Your GraphQL allows clients to request exactly the data they need from the server, providing a more efficient and flexible alternative for your REST API. As you know that when you're trying to have communication between your client and your server, usually we use our REST APIs for having those communications. And REST API uses HTTP protocol for having those communications, and it uses your HTTP. It uses your HTTP methods like your get, post, put, trace, and all that, right? So what exactly your GraphQL does is your GraphQL allows clients to request exactly the data which is needed from your server. Okay. It enables declarative data fetching. That is, it gives you a declaration on what exactly the data needs to be required. Like, for example, if you're giving the user ID as in query and you need only the name, but in your data you have your name, age, and the address. You only need the name. So you'll be able to fetch only that detail with the help of your declarative data fetching. As well as a GraphQL server provides a single endpoint where it receives queries and responds to them. In your REST API, what happens is when you're trying to have the communication, every request it sends from your client to your server, it has different endpoints which it has, and with the help of your get method, you're trying to have those informations to and fro from your server to your client. But with the help of your GraphQL, with a single endpoint, you will be able to fetch that information in a form of a query and bring back the information from your servers. GraphQL provides a more efficient, powerful, and flexible alternatives with regards to your traditional REST APIs. Now, with your GraphQL, clients can exactly request the data they need, and this helps in reducing your overfetching and underfetching of data. That is, bringing out the data, more data than required from what is needed for your client, and bringing less data than what is required to your client. So you can avoid these overfetching and underfetching of your data with the help of your GraphQL API. Now, how exactly the communication happens between your clients and your servers? You know that you have clients over here, that is your desktop and your mobile, for example. And with the help of your internet, you have your server and then you have your database. With the help of your get method, you try to have those communications between your client and your servers. This, as you send your HTTP request over your get method, it contacts the server contacts the database, and then the information is brought back with the help of your HTTP response. This is the common way of communicating between your client and your servers with the help of your internet. Now, what are the different characteristics of your GraphQL? So, as I already said that it is declarative. When we say declarative, the client will declare exactly which fields it is interested in, and the response will only include those properties. I gave an example, right? If you have the database has the data with the user ID, it is storing the data of your name, it has your address, it has your age, it has your gender. But then with the help of your declarative queries, you will be able to bring back exactly that field which you are interested in, and as a response from your servers, right? And then your GraphQL queries are also hierarchical. The data returned flows the shape of your query, like how we have your SQL queries. The same way you can have your GraphQL queries, and the data is structured in a hierarchical way, the way you have asked for, like you have your username, you have your password, you have your gender, age. So it gives you with the help of an hierarchical structure as in shape of your query. And then your GraphQL is a strongly typed API. When we say strongly typed, we mean that the data and its structures are defined explicitly and strictly with the schema, right? And then the types describe the capability of the values within your GraphQL servers. And then some of the types of data types, you can say, are already familiar with all the programmers. Like we have your Scala, that is your primitive values, like your strings, booleans, your numeric integers. Also, we have some advanced data types values such as your objects, right? So you can say that your GraphQL is it has a strongly typed characteristics wherein the data and its structures are defined explicitly and strictly within the schema. Now coming to the difference between your GraphQL and your REST API. Your REST API, that is your representational state transfer. Representational state transfer is an architectural style. It is not a protocol. It is just an API which will help you in communicating with your client and server with the help of your HTTP protocol. And then REST endpoints have fixed structures, and clients often need to make multiple requests to different endpoints to fetch related data. Right? Since it is not a single endpoint, you have different endpoints when you're trying to have the data being queried from your client to your server. Every request has an endpoint. Like you have your name, you want to fetch the name from your server, it has an endpoint. You want to fetch the password from your server, you have a different endpoint over there. So REST endpoints have fixed structures, and the clients often need to make multiple requests to different endpoints to fetch the related information. In GraphQL, there is a single endpoint. Even if you want to have multiple informations to be fetched from the server, with a single endpoint, with the help of your query, you will be able to fetch that information. And you can say that your GraphQL is therefore a single endpoint, and clients can request precisely the data that they want in a single query. You don't have to write multiple queries. You don't have to have multiple endpoints for having those requests being responded by your servers. And then you can say that GraphQL offers strong typing and introspection, allowing clients to discover the schemas and types at your runtime. So we said that the different types, we have primitive data types like your boolean, you have your string, you have your integer, and you have your advanced data types also like your objects. So those are defined at your runtime. Few more differences between your GraphQL and your REST API. We said that your GraphQL is an application layer server-side technology created by your Facebook to efficiently query existing data. So when you're trying to have those communications across your client and servers, you do that with the help of your query, similar to your SQL, like how you query the database. Similar structure is being used for querying to the database. And then your REST is a software architectural style that outlines a set of constraints for designing web services. And then your GraphQL adheres to a client-driven architecture, and your REST API adheres to your server-driven architecture. And then your GraphQL is organized in terms of a schema, right? When you're trying to have those communications, it's in terms of a schema wherein you are trying to have the query written for your schema and getting those informations. Here in your REST API, it is arranged in terms of your endpoints, and you will have multiple endpoints for multiple interactions between your client and server to fetch the data. And then the development speed is fast in GraphQL. The development speed is slow in your GraphQL. And then GraphQL has high consistency across all your platforms, and hard to get consistencies across all platforms in case of your REST API. Your GraphQL is strongly typed, and then your REST APIs are weakly typed. These are some of the differences between your GraphQL and your REST API. Coming on to the example of your REST API, you can see that I have written 3 endpoints for the get methods over here. Like, say if I have a client, and then I have a client and then I have a server. Now I want to get the username of a particular person who has ID is equal to 1, right? Now, when I'm trying to send this information from my client to my server, when the server is responding, it might give me the response of my username with the ID is equal to 1. It will give me the name, it will give me the age, it will give me the address. So this is overfetching of your data which is happening. Right? We asked only the ID and then it had to give us only the ID, but it is giving us the data with your name, age and your address as well. And then coming to your ID post, it has to give me only the post information. And then how many number of followers, it has to give me only the followers. So each time when we are trying to have separate information of your ID, your post and your followers, we are trying to have those communications at your client and your server. So 1 endpoint, 2 endpoint and 3 endpoints. So 3 API endpoints are required for having these informations being collected by your client to your servers. Whereas when it comes to your GraphQL API, it needs only one endpoint. So you can give that in form of a query, that you need users ID and then posts and then followers. You can give everything in one. So when you're trying to have the information from your client and server, one endpoint is required. So this also eliminates the overfetching and underfetching of data, of your data, right? So that's what the examples for your GraphQL. Now coming to the benefits of your GraphQL, one of the benefits is precise queries. You can write precise queries, that is client can request only the data they need. What will happen when they're trying to have those precise queries? It will help you in reducing your bandwidth usage and improving the performance. Such a great advantage it is having that it is reducing the bandwidth as well as it is improving the performance of how the query is running and how the client and server communication is happening, right? And then the next benefit is your strong typing, wherein GraphQL schemas enforce data types, reducing your runtime errors. Right? And then versioning, no need of versioning because clients request exactly what they need. There is no need of having those versions being stored or cached because the clients are requesting exactly what the data they need. And then introspection, clients can explore the schema, making it self-documenting. And then real-time data, GraphQL supports real-time subscriptions for live data updates. We have something called as subscriptions, some characteristics, or you can say some feature in your GraphQL called as subscriptions, which will help us in trying to have those real-time data being updated and captured as and when the changes are happening in your data. And then ecosystems, a growing ecosystem of tools and libraries supports for your GraphQL. Now coming to the challenges of your GraphQL. The first challenge is the complexity. When you're trying to write complex queries, that can be challenging for the client, right? When you have your nested queries or when you're trying to get the precise data, the complexity which you have in trying to write the queries may increase. And then the learning curve, that is the developers need to learn GraphQL specific syntaxes and concepts, right? Syntaxes and concepts need to be learned as a different language. That will also be challenging to the developers when they're trying to learn GraphQL. And then security, poorly designed schemas can lead to security vulnerabilities, like you have your denial of service attacks. And then caching can be more challenging with your dynamic queries. As in when you have your dynamic queries, caching becomes a great problem to face with or challenge to face. And then you have your tooling. Some legacy tools and services may not support your GraphQL. If you want to incorporate some add-ons, you want to have some tools to be incorporated, GraphQL might not support those services. Now coming to creating a GraphQL schema. The GraphQL schema defines the structures and capabilities of your API. Now your GraphQL consists of types, queries, mutations and subscriptions. We will see one by one what exactly are your types, queries, mutations and your subscriptions. You can see that types represent the structure of your data in your GraphQL schema, like whether it is a boolean, whether it is a string, whether it is an advanced data type like your objects. So these can be object types. For example, you have your user data and scalar types like your string, int, boolean or custom data types also, right? And then your types represent the data you can fetch and the relationships between them. What is the relationship between the data type you're trying to fetch is also defined by your types. So you can say that your GraphQL consists of your types, queries, mutations and your subscriptions, and your types are the represents the structure of your data in your GraphQL schema. Now you see in the example over here, we have two types. One is your user type and the other one is your post type. So each type has specific fields that represents the structure of your data, right? Specific fields like it has name, which is a string, it has email, which is a string, and then you can see that title is a string and body is a string, right? So you can see that the types represent the structure of your data in your GraphQL schema. Now coming to your queries define how client can read data from your GraphQL server. Obviously, you're trying to query. It means that you're trying to give a query to the server and the server will read what the query is and tries to give you the exact information by relating to the query, right? So the client needs to write it in such a way that the server understands. So your queries define how clients can read data from your GraphQL server. So they specify the entry points for retrieving data. Obviously, queries are the entry point for retrieving your data. Here we define queries to fetch your data, like you have your get user and you have your get post. Your get user allows clients to retrieve user information. When we say get user, for this ID we want the user information, and for this ID we want the post information is what we are trying to infer over here. So you can say that your queries specify the entry points for retrieving your data, and we have given examples how exactly the queries can be written. Like with the help of your get user, you're trying to retrieve the user information by providing the user ID, and with the help of your get post, you're trying to fetch the post details based on your post ID. Now coming to mutations. Mutations are similar to queries but are used for modifying data on the server, like performing your CRUD operations, create, update, delete. These sort of operations is what you're trying to perform with the help of your mutations. They perform operations like creating, updating or deleting your data. So you have mutations enable data modifications. You can say that mutations enables your data modifications. And then you have create user, you have create post, you have your update user. These are the mutations which you are trying to define over here. Create user and create post are used for adding users, new users, and post posts, whereas your update user allows client to update your user information. So here you are trying to create the user and the post. Here you are trying to update the user information. So you can say that mutations are actually similar to queries, but then they help in modifying the data with the help of your CRUD operations. Now coming to subscriptions. Your subscriptions enable real-time communication between your clients and your server. Real-time communications are enabled with the help of your subscriptions with your client and your servers. They define events that clients can subscribe to, allowing them to receive updates when specific data changes. Like you have some live updates happening. If you want that data to be changed, with the help of your subscription, you will be able to have those real-time changes being added onto your database. So here you can see that you have type subscription and the new post, you have post. So your subscription defines event that clients can subscribe to. Here in this case, you can see that new post subscription, which notifies clients whenever a new post is created. So with the help of your subscriptions, you will be able to capture the real-time communication between your clients and your servers. Now coming to understanding your types, fields, and your resolvers. Your types define the shape of your data. Your fields are the properties, the key value pairs, you can say, the properties or attributes associated with your type, and then they define what data can be requested when you're querying a type. What data can be requested when querying a type, that will be defined with the help of your fields. Here example, you have type product. You have type product over here. Here product has fields ID, name, and your price. You have your ID and you have your name, which is string data type, and then you have your price, which is of your float data type. So fields are attributes or properties associated with your type. Now coming to resolvers. Resolvers are functions responsible for fetching the actual data for a field when a query is executed. So with the help of your resolver function, you are responsible for getting the actual informations from your field when the query is getting executed. Now each field in your GraphQL schema must have a resolver associated with it. So it's always better to have a resolver with each field in your GraphQL schema. Resolvers are executed in response to a query and return the data for the corresponding field. So you can say that resolvers execute like your queries, and then it will try to return the data based on your corresponding fields. Like here we have resolver, we have user field. Here we are trying to fetch and return the user data which is based on the ID. So it returns the user data by the ID. Now coming to the example, we can see that the resolver of your user field queries a database to retrieve user data, and a resolver for your age field calculates the user's age based on your date of birth. So you have two resolvers over here. One is your query, which is using your user and ID. It is giving you or fetching and returning you the user data and your ID. And then you have your age of your user, which will calculate the age and returns your user's age. So you can say that your resolvers are functions which are responsible for fetching your actual data from the field when a query is executed. Now coming to your scalar and custom types in your GraphQL. Scalars represents your atomic types like your int, your string, your boolean, your float. These are some of your scalar data types. Now custom data types define complex data structures. Custom types are made up of fields, each with its own type, including other custom types or your scalar. So you can have a mix of your scalar and your custom types when you're trying to have your data types being defined for your GraphQL. Now example here, you can see that user is a custom type field which has your ID, which has your username, which has your email, and which has your post. So the post field is an array of another custom type post. So you can see that when we try to define that in a square bracket, it is an array, right? So we are using a user as a custom field type, wherein we have your ID, your username, and your email, and your post. Your post is again a field which is an array of another custom type for your post. Now coming to creating and executing your GraphQL queries. So in your GraphQL, clients create queries to request your data, and then these queries are sent to the server via a single endpoint. Now coming to creating and executing your GraphQL queries. In your GraphQL, clients create queries to request some of your data from your server, and then the queries are sent to the server via a single endpoint. Unlike your REST APIs, your queries in your GraphQL are sent via your single endpoint. And then queries follow a hierarchical structure to define the data shape. Now here you can see in this, you have a query wherein for this user ID 123, you want the name and email to be fetched from your database. So you can say that queries are sent to the server via your single data point. In your REST API, if you had to give out the information, bring out the information from your servers, you had to create a single endpoint for fetching the name, single endpoint for fetching your email ID. But here with the help of your single endpoint, you're able to get the requested data from your server. Now coming to selecting specific fields in your queries, clients can specify which fields they want to retrieve. Hence the overfetching and underfetching characteristics of features which your GraphQL provides is one of the characteristics over here. Like clients can specify which fields they want to retrieve. This reduces overfetching of your unnecessary data. So here in this example, you can see that the query fetches the title of the post and the name of the author. For this post ID 456, it is fetching the title and the name of the author in this query. Coming to aliases and fragments for your query optimization. In your GraphQL, we have some feature called as aliases and fragments, which will help us in having those query optimizations by allowing you to construct more efficient and reusable queries. Aliases allows renaming fields for clarity and avoiding conflicts. With the help of your aliases, you will be able to avoid the conflicts between the different names in your queries, and you will be able to fetch the appropriate information from your server when you're trying to send the query from your client to your servers. Fragments enable reusing common field sections and enhances your code readability and maintainability, whereas your aliases will help you in trying to avoid your conflicts. So both your aliases and fragments helps you in attaining your performance of your queries, and it helps you in keeping the queries organized and easy to maintain, as well as it will help you in trying to measure the impact of your API response time, like the time taken from when the query is sent and the response is brought back from your server. It will help you in trying to enhance your API response time. Optimize as needed for your specific use cases. You will be able to use aliases and fragments and optimize as and when it is required for your use case. Now, coming to an example for your fragments and your aliases. So this example will define a fragment to retrieve common author details. Like you have the keyword called as fragment, and you have your author details. On your author, you are trying to fetch the ID, name, and your email. So here you are trying to define a fragment named author details. right? You're trying to define author details that gives common author details such as your ID, name and your email. So we use aliases author 1 and author 2 to request information for two different authors. Like here you can see in the next example, you have used aliases for bringing out author 1 and author 2 details. So with the help of your fragments and aliases, you will be able to have your query optimizations being done and avoid conflicts, as well as helps you in trying to have the code readability. So that's about your aliases and your fragments. Now coming to making changes to data with your mutations. Mutations are used to modify data on your server. As well as we saw the examples of your mutations, how it will help you in trying to have those CUDA operations, that is create, update, delete, being handled, modify your queries, right? So mutations are used to modify data on your server. So they are the counterparts to queries for data retrieval. Mutations can perform actions like creating, updating or deleting your records. We already saw how to do that. So with the help of your mutation here, you're trying to create a new user with the specified name and your email. So you're trying to create the name and you're trying to create the email with the help of your specified name and your email in form of your mutations. Now coming to your input types and your variables, your mutations often require your input types. When we say input types, we're trying to define the shape of your expected output, how exactly the output should look like. We are trying to define with the help of your input types, and the variables are used to pass dynamic values into your mutation. Not static values. Your variables are used to pass your dynamic values into your mutation. So here in your input types, you have your create user input, and variables, we have your input, that is name, and your values as your variables, which are the dynamic input for your name and your email. So mutations often require input types, and these input types will help you in trying to define the shape of your expected output, and variables help you in passing the dynamic values into your mutation. Now coming to managing errors in your GraphQL mutations. So mutations may encounter errors like you have your validation failure errors, or it may also perceive in having database conflicts. So your GraphQL provides structured error handling capability when the error is happening in your mutation. So you can say that your errors are returned as a part of response, allowing clients to handle them gracefully. So you will have a response, what exactly went wrong and what is the error, so that you will be able to handle the error appropriately. So here in your mutations, you are trying to update the user with ID 123 with the input name as updated name. This is what you are trying to do now. Now, what is the error response we are trying to get? We are trying to get error response message as user not found. We are trying to have the username being changed for your ID 123, right? So here it is trying to give us an error that the username is not found, and then it is trying to give us the line numbers and what is the path where the error is and all that. So your mutations will help you in trying to encounter your errors. If you have errors like your validation failure or database conflicts, these mutations will provide you a way of error handling wherein the responses are given in such a way that you will be able to handle those errors. Now coming to your benefits of GraphQL and database operations, you have your simplified data fetching and manipulation. This is one of your benefits. The reduced overfetching and underfetching. As we said, your overfetching will try to have the bandwidth usage being increased, right? And underfetching also will not help when you're trying to have a query written to get the appropriate information. If you're not getting that appropriate information, then underfetching happens, right? So it will help you in trying to reduce your overfetching and underfetching. And then enhanced query efficiencies is there, as we have only a single endpoint. The query efficiencies is increased, and one-stop solution for API and your database needs, as well as it will help you in trying to improve your developer experience. Now coming to your GraphQL development tools. In your GraphQL development tools, we have something called as your Apollo client. Your Apollo client is a powerful tool for handling your GraphQL operations at your client side. And then it has features such as you have your caching features, you have your error handling features, you have your state management features, and it will help you in making it. This Apollo client is an excellent choice for efficient GraphQL client-side operations. Okay, so you have some of your development tool called as Apollo client, which will help you in trying to have those, a powerful tool which will help you in trying to handle your GraphQL operations at your client side. We also have GraphQL Playground. So this is your one of the tool which is an interactive web-based tool that simplifies testing and exploring your GraphQL APIs. So it allows developers to expose and execute your queries, your mutations. If you have subscriptions wherein you want to have your dynamic updates happening as and when the user data is changed, that will be helped out in your GraphQL Playground tool, and then making it an invaluable resource for your GraphQL development. So two development tools we saw. One is your Apollo client and the other one is your GraphQL Playground. And then we also have something called as Apollo server. So it's a versatile and efficient solution for building your GraphQL servers. So Apollo client for building your client queries, and then you have your Apollo servers, which will help you in trying to have build your GraphQL servers. So Apollo server streamlines your GraphQL development by providing essential middlewares and data resources for connecting between the different data stores what you have in your servers. And it's an excellent choice for creating robust and performance GraphQL APIs. And then we also have Express with GraphQL, which will discover the flexibility of integrating your GraphQL in your Express.js, which is a popular framework for your Node.js. So it will help you in trying to leverage the power of Express to create a highly customizable GraphQL server, which will help us in trying to meet the defined project requirements. It will also help you in trying to explore the benefits of this combination by building scalable and feature-rich APIs. So we saw Apollo server and we saw Express with GraphQL, which will help us in trying to integrate your GraphQL with your Express.js, which is a popular Node.js framework. Now coming to community and resources, we have GraphQL community. So you can immerse yourself in your GraphQL community where developers all around the world share the knowledge and insights. Participants in the form of your blogs, you have your forums, you can attend conferences and join local meets and connect with the fellows of your GraphQL people. And engaging with the community can provide valuable support and inspiration for your GraphQL projects. And then learning resources, you have a lot of learning materials that will enhance your GraphQL skills. You can explore your books, you can explore tutorials, you have online courses, you have blogs, you have comprehensive documentations are there, which will help you in trying to learn your GraphQL. And these resources are your companions to the path of becoming proficient for your GraphQL developers or becoming a GraphQL developer. Now coming to the summary, in your summary we saw that your GraphQL allows clients to request exactly the same data from your server, providing a more efficient and flexible alternative for your REST API. We said that your REST API is not a protocol, it's just an API which will help us in trying to communicate across your client and servers with the help of your HTTP protocol. And then the characteristics of GraphQL include it is declarative, hierarchical in structure, and then strongly typed. And then your GraphQL schema defines the structures and capabilities of your APIs and consists of types. You have queries, you have subscriptions, and you have mutations. And then we also have resolver functions which are responsible for fetching the actual data of your field when the query is executed. And then we also have features like Aliases and Fragments, which are powerful features which will help you in having those query optimizations, allowing you to construct more efficient and reusable queries. Thank you so much.